Hi there, let's answer topic 1 questions. Question 1 wants to know what causes objects in the sky to rise in the east and to set in the west. And the answer is, of course, the Earth's rotation. The Earth rotates counterclockwise as it goes around the Sun. And it goes around the Sun in this direction. So clockwise around the Sun, counterclockwise on its axis. What is a frame of reference? And what do we use on Earth as a frame of reference? It's a set of axes of any kind that is used to describe positions. And on Earth, we use the equator and the prime meridian. And the equator tells us latitude. And the prime meridian longitude. So this is 0 longitude, the equator is 0 latitude. So latitude above and below the equator, longitude west and east of the prime meridian. Next, what's a celestial body? And 5 things that the ancient Egyptians learnt about celestial bodies. So a celestial body is anything in the sky that we see, and these are 3 things. Of course, they are stars, planets, the moon, and the sun. And there are 5 things that we ancient people have learnt. One is stars are unchanging patterns called constellations. The constellations appear to move, but that's due to the rotation of the Earth. Okay, so it's the Earth that's moving, not... Oops, let's go back. So the rotation of the Earth. On successive days, so every day a star will set 4 minutes earlier in the sun. And why is that? Because here's the sun and the Earth is going around the sun, so all these stars or constellations up here are going to be a little bit different. The sun rises and sets at a different rate than the stars, and the moon rises and sets at a different rate. And the 5th thing, 5 other bodies rise and set at different rates. And so the planets, basically, that we can see. Next, what 2 coordinates are needed to measure celestial bodies? The altitude and the azimuth are needed to measure celestial bodies. So the altitude goes something like this. Here's our horizon, and let's say we see an object in the sky. If we wanted to describe its altitude from the horizon, that's 0 degrees, we would go how many degrees up? So whatever this angle is, that would be our altitude. It can be a maximum of 90 degrees. And then that's it. It can't be 91 degrees because we would just change direction. And then the azimuth is looking down on the Earth. So here's our flat plane. Looking down, we start at north and we rotate clockwise around this way up to 300. So this would be 90 degrees azimuth, this would be 180, this would be 270, and then back to north again would be 360. So there's no such thing as a 360 degree azimuth, and there's no such thing as a 91 degree altitude. Next, why do we use the stars as a frame of reference to track the movement of other celestial bodies? Well, to track the motion of celestial bodies, that is not caused by the motion of the Earth is one reason, and the only motion that stars exhibit is basically because of the Earth moving. What's a Earth-centered or geocentric model? The Earth is the center of the universe, and all other celestial bodies rotate around it. And so let's talk about that. Let's talk about contributions different people made: Aristotle, Ptolemy, and Copernicus. So Aristotle came up with the geocentric model of the Earth, and he believed that the Earth was at the center and all other celestial bodies traveled in spheres around the Earth. Now this wasn't true. Ptolemy came up with the idea of epicycles and then later explained the concept of retrograde motion. So it appeared that objects in the sky from Earth would travel backwards. And Ptolemy said, well, that's because, let's say this is the moon. Let's say the moon is traveling around this way, and every once in a while it would seem to travel backwards compared to, say, a planet like Mars. And so why was this? Well, Ptolemy said, well, they go like this around the Earth, but then they do these little dip-de-doos, little epicycles, and then they keep going, and then they'll do a little backtrack or an epicycle. And then Copernicus, he came up with the sun-centered or heliocentric model of the Earth. And finally, what is the sun-centered model of the universe? That's the Earth revolves around the sun. So that's our recording for this one.